Okay, today we're going to look at identifying patterns of numbers that are arithmetic. And what that means is you're going to look at sequences of numbers, and a sequence of number is an ordered list of numbers. So for example, if you look down here, this is an ordered set of numbers. So you have 3, 6, 9, 12, 15. So if we're going to analyze this. Oh, my pencil broke. 3, 6, 9, 12, 15. Let me get some information to you first. This is a sequence of numbers separated by commas, and it's in a certain order. What we call this term right here, we're going to call it a sub 1. That's the first term in the sequence. 6 would be a sub 2. 9 would be a sub 3. 12 would be a sub 4. And 15 would be a sub 5. Dot, dot, dot means the pattern continues. Okay? So, if I ask you to look at this pattern of numbers and give me the next 3 terms, if I asked you for the next 3 terms in the sequence, can you tell me what they are? What would be the 6th term? What would be the 7th term? And what would be the 8th term?
24.
What would be the 6th term?
18.
18. How did you get 18?
Add 3.
How did you know to add 3? Because to get from term 1 to term 2, they added 3. We call this the common difference. If the pattern has a common difference, now it could be going the other way. If this sequence was going 15, 12, 9, 6, and 3, and so on, the common difference would be negative 3, because we're going down by 3s, okay? So, if you have a pattern where you're either adding or subtracting a number, a set number, it could be a positive number or a negative number, we will call this an arithmetic sequence. Arithmetic means you're adding or subtracting the same number to get the next term. So how would you get the next term, the 7th term? And you get 21. Add 3 and you get 24. How would you get the 9th term? Add 3. How would you get the 100th term?
Add 300.
Okay, well, you would have to know the previous term, which would be, if I wanted the 100th term, you would take the 99th term, whatever it is, and you would add 3 to it to get that term. Well, we have a formula. It's called the recursive formula. The recursive formula looks like this. You will state the first term in the sequence. So if I asked you to write a recursive formula for this, you state the first term, which is 3. Then to find any term in the sequence, you must know the previous term. This means previous term. Previous term is a sub n minus 1. So if you want the 100th term, a sub 100, you have to know the 99th term, and then you want to add the common difference, which in this case it was 3. So a recursive formula for this, recursive, you state the first term. What is it? Then to find any term in the sequence, you must know the previous term plus what the common difference is. So in this particular problem, to write a recursive formula, you're going to say a sub 1 is 3, and a sub n is the previous term plus the common difference, which is 3. That's a recursive formula. Now, why is this formula not all that it's cracked out to be? It's good, but you can only, if I asked you, hey, what's the 100th term? You'd have to know the 99th term and then add 3 to that. If I want the 1000th term, you have to find the 999th term and add 3 to that. So you have to go in order. You have to keep adding 3. Okay? Now, there's another formula. It's called explicit. This is recursive. Recursive is only good when you want to find the next term in the sequence. So if someone gives you the 5th term and they give you the common difference, you can find the next term by adding whatever the common difference is. But when you want to jump and find the 100th term, and you know the pattern, this is what you're going to use. It's called the explicit formula. The explicit formula for arithmetic looks like this. To find a term in the sequence, and this is in your notes, it's a sub 1. What does a sub 1 stand for? The first term in the sequence, plus n minus 1 times the common difference. So n, if I'm looking for the 100th term in this pattern of numbers, so continuing on this pattern, if I want to jump to term 100, as long as I know the first term, which is defined as 3, you're going to find the 100th term by doing 100 minus 1, and the common difference is 3. So in other words, 99 times 3, and then add 3. So what's 99 times 3?
297.
99 times 3 is 297 plus 3 is 300. I'm highlighting what we're doing today. That's what we're doing today. Okay? So that's the big picture. You're going to come up with 2 formulas. And in your notes, this is what you have here. So a recursive formula is defined. It has 2 parts. It has an initial condition. You have to know the first term. And then a sub n minus 1 means, this just means the previous term. Previous to what? Whatever n is. So n minus 1 is going back a term, and then you add your common difference. Whereas the explicit formula looks like this. You have to know, and this should say a sub 1. I don't know why it doesn't say that. It should say a sub 1, which is your first term in the sequence, plus n is the term you're looking for, minus 1. So actually the previous term, like if you're looking for the 100th term, you look at the 99th term, and then times d. So let's look at our first example. We just did this one. The question says, is this arithmetic? And the answer is yes. We figured it out. Why is it arithmetic? Because you're adding 3 to each term. So yes, this one is arithmetic. Yes, it is. How about B? You've got 1, 4, 9, 16, and 25. Do you see a common difference? Meaning, can you add or subtract a number that's the same from the first term to the second term to the third term to the fourth term? No, you can't, because it goes 3, 5, 7, 9. Now, is there a common second difference? Yes, there is, but that's not what this is about. This is strictly the first, has to be the first difference is common. We've talked about second difference, and that's quadratic, but this is not arithmetic. Arithmetic means it's going to be linear. It's a linear function. So this one is no. Okay? Now I want to try got it with you. Is this sequence an arithmetic sequence, yes or no?
No.
What are they doing? They're adding 2, then they're adding 4, and then they're adding 8. So this one is no. It is not. You are absolutely correct. What about this next one?
Yeah.
Why is it?
Yeah.
You're adding 4 to each term. Now, stay here for a second. Let's take this one step further. What if I ask you to write the 2 formulas? Let's do the recursive one first. a recursive formula goes like this. You state the first term, the initial term has to be stated, which in this case it's 1. And then to find any term in the sequence, you take the previous term, which we don't know which one they're looking for, so it's you just write a sub n minus 1, and you're going to add the d value, and what is the d value in this case? 4. So that is your recursive formula right there. Your explicit formula looks like this. It's a sub n is equal to, it's the first term in the sequence, which is 1, plus n minus 1 times the common difference, which is 4. And that's that. Why we like explicit more than anything is because we can find any term in the sequence. We can jump and find, if I wanted to find the 100th term, I'm going to put n as 100. So it'd be 99 times 4 plus 1. And I can jump and find any term. Okay, next page. Check this one out. Problem 2. Let's read it. It says, what is the 100th term? The 100th term of the sequence that begins with 6 and then 11 and so forth. Now, already, they defined it. They said it is arithmetic. I want the 100th term. What is the 100th term? That's my question. Well, in this case, if it's arithmetic, how did you go from 6 to 11? Added 5. Remember, arithmetic means you're adding or subtracting a common number. The same, it's called the common difference. That's your d value. So, if I want the 100th term, if I did this recursively, it would take me a long time. To find the 3rd term, I would have to add 5. The 4th term, I'd have to add 5 to that. And in order to get the 100th term, I'd have to know the 99th term, and I could keep adding 5, but that is just too much. So this particular problem, you definitely want the explicit formula. The explicit formula looks like this, and the more you write it, it's a sub n. It's the first term plus n minus 1 common differences. So, what is the first term in this sequence? I keep breaking my pencils. What's the first term? 6. So if I want the 100th term, I take the number 6, which is the first term. I'm going to do 100, n is 100, minus 1, and what's my common difference? 5. So in other words, what's 6 plus 99 times 5? Well, what's 99 times 5? It's 495. And then plus 6 is what? 501. And check this out, 501 is your 100th term. Okay? Next one, a little different. This one's a little different. They give you 100, blank, blank, 82, blank, blank, blank. I want the 2nd and the 3rd term. But I know the first term and I know the 4th term. Now, this is the easiest way, I think, because I've been doing this for a while. You guys are really good at the slope formula, right? Well, think of this, a sub 1, 100. Think of this as 1, 100. This point would be 2 something. This would be 3 something. This would be 4 something, 82, actually, we know it, 482. You're going to take these 2 points and pretend like you're finding the slope of these 2 points. Do you remember how to do this? What's the slope formula? It's the difference of the y's, so 100 minus 82 over 1 minus 4. What's 100 minus 82? 18. What's 1 minus 4? Negative 3. So m, which is really d, is minus 6. So what's happening? This is going down by 6. So if I took 100 and I went down 6, what would the second term be? What is it? 94. And if I go down 6, what would it be? 88. And if I go down 6, I get 82. So you're actually doing the recursive formula in this one. You're taking the previous term and you're adding the common difference, which is negative 6. Okay? Let's try these two, 2A and B. How would you figure out the 46th term if I give you this sequence, 3, 5, 7? Okay, now 3, 5, 7. And I want a 46. How will I figure this out? Well, I'm going to use the explicit formula. A sub n, it's the first term plus n minus 1 times d. Well, what is the first term in this sequence? What is it? 3. And I'm looking for the 46th term. So I'm going to do 46 minus 1. What are we doing to get from 3 to 5 and from 5 to 7? What are they doing?
Adding 2.
You're adding 2. So d is 2. So to find the 46th term, this is what you would do. What is 45 times 2? 90. What's 90 plus 3? 93. The 46th term is 93. Okay?
Don't you multiply 3 times 46?
Not all the time, no, because it doesn't always start with 1.
Okay.
Okay? Next. Yes.
Can it start with a negative number,
Huh?
like in the sequence?
Can it start with a negative? Yes.
So then you just.
And we're
add-
going to do some
Okay.
on the homework. We're going to do some. You'll see it. And it works out, trust me. It works out all the time. Okay, let's see if you can do B. B is like the B above. What are the second and third terms of this sequence? So we know the first term is 80, and we know the fourth term is 125. How did I tell you to find the common difference? 80 minus 125, or you could do 125 minus 80 over 1 minus 4. So what do you get? What's 80 minus 125? Anybody? Negative 45. And what's 1 minus 4?
Negative 3.
And what is negative 45 over negative 3? It is a 15. Now, does this make sense? Is this thing going up by 15? It sure is. So what would be the second term? What's 80 plus 15?
95.
95. What's 95 plus 15? 110. And let's double check. What's 110 plus 120? What's 110 plus 15? 125. So these are the two middle, the second and third term. Okay? What is the arithmetic mean? It is simply the average of two numbers. These are actually very easy. So they're going to give you two terms, and the middle term is missing. All you have to do is average. This says x plus y over 2. So if you get two numbers, like for example, they give you 15 blank 59. How do you find this middle term? All you're doing is finding the average. Add 15 and 59 and divide by 2. So what you get is 74 over 2, which is 37. So 37 is the middle number here. Okay? Let's try 3A. The 9th and the 11th term is given. So the 9th term is 132. The 10th term, we need to figure it out. And the 11th term is 98. How are you going to find out the middle term? Add these up. and divide by 2. Tell me what you get. Anyone? 115 is the middle term. Okay, we have a story problem. Okay, sports arena. It says the number of seats in the first 13 rows in a section of an arena form an arithmetic sequence. So row 1 and row 2 are shown in the diagram. And it says it right here. Row 1 has 14 seats. Row 2 has how many seats? And it is arithmetic. It tells you how many seats are in row 13. How would you do this problem? How many are in row 13? Well, what's your formula? We're going to do a sub 13. It's the first term plus n minus 1 times d. That's your formula. Well, what is the first term? How many seats are in the first row? 14. What are we looking for? The 13th row. So it's 13 minus 1. How did it go from 14 to 16? What did we do? We added 2. So simply, all you do is that. What is 13 minus 1? 12. What's 12 times 2? 24. What's 24 plus 14?
38.
There's 38 seats in row 13. Easy? Okay, you try got it 4. It says the number of seats in the first 16 rows of in a curved section of another arena form an arithmetic sequence. So you want to know that it's arithmetic. There's 20 seats in row 1. And 23 seats in row 2. How many seats are in row 16? What would you do? Anyone?
Would be 65.
Yep. Thank you very much. 65 seats are in row 16. Do you get this?
Yes.
Okay, the next part is your homework.